All right, we're going to get through this first page reasonably quick. We're only covering two things. We are covering precision and accuracy. All right, so we're going to talk about reporting with precision and accuracy, and we're going to define those two things. So precision is the level of detail of a measurement. Really what it means is the smallest unit is the more precise. So that just means an inch is more precise than a foot. Right? If you're going to wear a shoe, you want something within half an inch, not half a foot of your shoe size, right? So sometimes you want to be more precise. And what's also nice is if you're accurate. All right? Accuracy is how close a given measurement or value is to the actual measurement. So let's go look at those. Right down here, we have complete the table for the more precise measurement. So this is talking about precision. So what I'm going to do is I'm going to talk about the smallest unit. That's in grams, but this one has both grams and tenths of a gram. So the smallest unit is a tenth of a gram, right? If you look at this, these are ounces, but this one has tenths and hundredths of an ounce, while this one only has tenths of an ounce. So 1/100th of an ounce is the most precise. The smallest one. This one's in centimeters. This is in meters. So centimeters, 1 centimeter, that's the smallest unit on there, is going to be the most precise. This one is in feet and inches. Alright, this one's in feet and inches. This one's in inches, and that right there is a tenth of an inch. So it's 1/10 of an inch. So if I do that, the most precise measurement comes from 4.3 grams. Right here becomes 5.71 ounces. Right here, the most precise was the 422 centimeters. And on this one, the most precise was 7.2 inches. All right, not too bad, right? So let's go one further. Eric is a lab technician. Every week he needs to test the scales in the lab to make sure they are accurate. So now we're talking about accuracies, right? He uses a standard mass that's exactly 8 grams and gets the following results. So he's measuring something that's 8 grams, right? So this one measured over by 2/100ths of a gram. This one measured under by 1/10 of a gram. This one measured over by, wow, 29 thousandths of a gram. All right. So it looks like the most precise scale, right? Let's just talk about precise. This isn't accurate. The most precise, that measures hundredths of a gram, tenths of a gram, thousandths of a gram. So that is definitely the most precise scale, which is this one. That's the one with thousandths of a gram. That's scale 3, all right? Because it measures all the way to a thousandth of a gram. Even though that's 9 thousandths, it does 1, 2, 3, 4, 5, 6, 7, 8, 9 thousandths, all right? Again, we're just talking about precision right now. Let's go one more. We're gonna hit this question right here. And it says, for accuracy, all right? So if you went back over there, and this is absolute value, you can put this in your calculator. The first one was 8.02, which gives you -2/100ths, but absolute value makes it positive. So this one was within 2/100ths of the exact weight. This one was 7.9, which was within 1/10 of the exact rate. And this one is 8.029, which is in what we got? 0.029, 29 thousandths. Well, if we do this, scale 1, that's the closest, right? That's the closest to the actual weight of 8 that they gave, which is 8.02 is the most accurate because 0.02 is a smaller measurement than 0.029. That means it's a closer distance than this one, which is even a smaller measurement than 1/10. All right. Given two measurements of the same quantity, is it possible that the most precise measurement is not the most accurate? Well, why, yes, it is. Yes. And I'm just going to say that just happened. Scale 3 was more precise and less accurate. All right. So I'm going to stop right there, and we'll talk to you guys soon.